In this video, we're going to be talking about the multiplicity of zeros and how that's going to affect the sketch of a polynomial function. So I'm going to start by just discussing what multiplicity is, and it's essentially the amount of times that a root of a polynomial function is repeated. And there are various outcomes, and those outcomes will have a different impact on the graph of a polynomial function. So to start, I've given you an example of a sketched out polynomial function off to the left. I'm calling it p of x. You'll notice that as we read it from left to right, as it comes down to its first x-intercept or 0, I'll call this at point A, the graph bounces off of that x-intercept. That suggests a certain multiplicity. As we continue reading from left to right, and we get to our next x-intercept or root, and I'll call this point B, it doesn't bounce, it doesn't go straight through, but it sort of wiggles through, so I'm going to call that a wiggle. And then when I get to my third point, or my third root, my third x-intercept, that'll be point C, and this one just passes right through. It doesn't bounce, it doesn't wiggle, it just crosses from one side to the other, so we'll call that a pass-through. And these three terms, the bounce, the wiggle, and the pass-through, are the three essentially different types of behaviors that could result due to this thing called multiplicity. So now moving to the other side of the page, we have three examples to explore this a little further. The first is the polynomial function y equals x minus 3. And as you may have guessed, this is just the equation of a line. And if I wanted to find the x-intercept, or the root, I would let y equal 0 and solve for x. So we get an x-intercept of 3. Now we also have a y-intercept of negative 3, if we think of y equals mx plus b. So a y-intercept at negative 3. And this is just the graph of a line, so I'm just going to connect these 2 points and extend a little further beyond them. Okay, so what can we take away from this? Well, first off, what we have here, if we look at the three options from the graph to the left, the bounce, the wiggle, and the pass-through, this would be a case of just a pass-through. And the connection that I want you to make is this x-intercept of 3 came from this factor up here, and this factor happened one time. The fact that that's a 1 is important because the 1 correlates to a pass-through. To contrast that, we're going to look at the second example, which is y equals x minus 3 squared. And this is a quadratic, and the graph of a quadratic looks like a parabola. And I'm going to start by finding the x-intercept. So I'll set y equal to 0 and solve for x. Now again, I get x equals 3, which is exactly what happened in case number 1. So this begs the question, well, how are these going to be different? In case 1, we had a pass-through. Is it going to be a pass-through again? The answer is no, and that's because this function is a parabola that's been shifted to the right 3 units. So I've gone ahead and I've sketched that, and if we use our three outcomes from the example over here to the left, bounce, wiggle, and pass-through, this is obviously a bounce. And the connection that I want you to make here is that if we look at the original function, that factor, x minus 3, which gave us the 0 or the root of 3, had a power of 2. So in summary so far, if an x-intercept came from a factor which happened one time, we had a pass-through. If an x-intercept came from a factor that happened 2 times, it was a bounce. Now we're going to look at a case where the factor happens 3 times. And I bet you can already guess what's going to happen. So I'm going to go ahead and let y equal 0 and solve for x. Cube rooting both sides, I get 0. And ultimately x equals 3. In your school, when you studied basic shapes, you might have looked at the basic shape of y equals x cubed. At my school, we call this a wiggle. So this is just a wiggle that's been moved 3 units to the right. So as you may have already anticipated, the behavior that we see as the graph crosses at that point 3, it's not a pass-through, it's not a bounce, so we call this a wiggle. And that's because this x-intercept of x equals 3 came from a factor which happened 3 times. So once again, if an x-intercept comes from a factor that happens one time, we get a pass-through. If an x-intercept comes from a factor that happens 2 times, we get a bounce. And if we have an x-intercept that comes from a factor that happens 3 times, we get a wiggle. And that begs the question, well, what happens if the power of that factor is 4 or 5 or 6? And basically, the pattern just continues. So I'm going to make a chart off to the side here. And the chart's going to be number of occurrences. And I'm going to say 1. And I'm going to say even. And then I'm going to say odd, not 1. And then underneath that, I'll put behavior. Now, we said if the factor had a power that was 1, it was going to be a pass-through. If it was 2 times, it was a bounce. And that's going to be the case, actually, for any even power. And if it's an odd power, like 3 or 5 or 7, but not 1, because we already have that case over here. So 3, 5, or 7, that's going to be the wiggle. So this little chart here summarizes the 3 possible outcomes that you might have for these different types of powers. And I'm going to close by just looking at the graphing calculator and showing you some of these higher powers like 4, 5, and 6, and show you that they still adhere to this chart down here. Okay, so I've turned the calculator on. Let's go to the y equals screen, and let's put in x minus 3. And we'll do a zoom 6, just to show you that it's a pass-through at 3. Now if I go ahead and I change this to squared, we expect to see a bounce. There you go, there's your bounce. I'm going to change this now to a cubed, and we expect to see a wiggle. There's your wiggle. And now we'll make this to the power of 4. 4 is even, so if we look at this chart over here, we expect to see a bounce. There's the bounce. And if we change this to a 5, 5 is a power that's odd, but it's not 1, so we expect to see a wiggle. And the pattern continues. Now, every year that I teach this, I always have a student who wants to know, how does x squared, which is a bounce, differ from x to the 4th, which is also a bounce? So maybe I'll just finish by showing you those at the same time and see how they're a little bit different. So both of these factors have powers that are even, so they're both going to bounce. Let's see how they differ. I'll make one of these thicker so we can see a little bit better. I'm going to change the window just a little bit. Instead of starting at -10, I'm going to start at -1. And instead of ending at 10, I'm going to end at 6. And there's nothing happening down below the x-axis, so I'll start this at -1. So let's see if we can see the difference. This is the regular bounce, because it's squared. And the next one's x to the 4th. So they're both bounces, but they do have slightly different behavior. And that's something I'll let you explore a little bit more on your own. So here we have multiplicity of zeros.